Alright, so in this problem we're going to look at the atomic radius, and in particular we're going to take cesium, fluorine, barium, boron, and nitrogen and put them in order of increasing atomic radius. So really quickly, just to review, remember that when we're looking at atomic radius, as you go across a row, you're going to decrease the radius because you have a limited increase in shielding, many more protons, and therefore your effective nuclear charge is higher. So you can see these repeating periods dropping here. This is as we're coming across a row. Okay, but if you want to look at the jumps that happen, okay, right here is hydrogen, helium, the 1s1, 1s2. Then when we jump to n equals 2 to a new shell, we go into the 2s orbital here with lithium. You can see there's a huge jump in radius. Drops a little bit to beryllium as we're coming across the row, continues to drop through the 2p, and then again there's another jump as we go now to the 3s to n equals 3. So every time you go to a new shell, it gets a lot larger, and as you come across the row towards the noble gases, because the effective nuclear charge is increasing, it's pulling everything in tighter, and you're going to end up getting smaller and smaller and smaller, relatively speaking. So now all we have to do in order to solve this is figure out where these different elements are on the periodic table and take a look at that. Okay, so pull up a periodic table here, and I'm just going to highlight where the different things we're looking at are here. So cesium down here in the lower left, okay, in the n equals 6. Fluorine is a halogen in the upper right here. Barium right next to cesium. Boron also in the second period, and nitrogen also there. So you can see we have two major groupings here that we're talking about, and we can sort of figure out the relevant part here between those, and then we can figure out where they sit overall. So down and to the left, okay, we have n equals 6, so we're out in the 6th shell, and we're way to the left, so very low effective nuclear charge, relatively speaking. Cesium and barium are going to be sort of entirely by themselves here. We don't have to worry about those. So in terms of size, we can take a quick look and say that cesium, which is further to the left than barium, has a little bit less effective nuclear charge, therefore it is the biggest. So at the end of this, we're going to have cesium as the largest. Okay, and the next problem now is going to be looking at what is in front of it. Well, barium is clearly the one that's right next to it, so barium is going to be a little bit smaller than cesium, mostly because we add a proton, but we don't add that much shielding. Okay, now we have to figure out the other three, the boron, the nitrogen, and the fluorine. And if we take a look at this, we can see that they are all in the second period, so we don't need to worry about which shell they're in. We can simply deal with the fact that fluorine is furthest to the right, therefore should be the smallest. Nitrogen is to the left, should have a little bit less effective nuclear charge, and therefore should be a little bit bigger. And boron, which only has that 2p1 electron configuration, 2s2, 2p1 from after helium, it is going to be the least of them. So therefore fluorine with the strongest will be the smallest, followed by nitrogen, followed by boron. And there you go, you've got the order.